Okay? So you're both right here. So when we look at this, if the force is the same,
We're gonna be something one day.
Oh, for sure.
if the force is the same, but the car has a small mass, it's going to have a large acceleration. But the truck has a large mass, which means it's going to have a small acceleration. So people thought for a long time, and naive people think, and I don't mean naive as a person, I mean naive in terms of Newtonian physics concepts, that because the truck is more massive, it's going to apply a larger force. Because you know that the results are different, and they think that, oh, it's the force that caused the result, but it's not. The force is the same, it's the difference in mass that changes the result.
It's a learning environment.
God. How would Dr. G feel about this? Yeah.
Yeah.
Is that cool?
So,
So that's our force construct, okay? Now, let's bridge this with our centripetal concept, because that'll make a lot more sense now.
Okay, sick.
we should have more room.
I got a little armrest. I'm sure it's like,
So, we talked about earlier that the centripetal acceleration is equal to v squared over r, correct?
yeah.
You with me on that? So that's on the paper here. How am I going to find the centripetal force? Okay, well, we saw earlier that you could calculate the acceleration of the object if you take the unbalanced force, the net unbalanced force, and divide by the mass, right? So if I rearrange this mathematically, you can calculate the net force if you know the mass times the acceleration. Right? You with me on that? So how am I going to find the centripetal force then?
Well, it'd be just mass times v squared over r. So mv squared over r.
So, because net force is mass times acceleration, centripetal force is mass times
Acceleration.
centripetal acceleration, which Simon pointed out very astutely is mv squared over r. The centripetal force is the nickname for the net force. Those are not different things. These are the same thing.
Sorry.
So if we look at this stopper again, okay, if we look at this stopper again, as it goes around a circle, let's look down here at the bottom. What are the forces?
Something.
The Earth is pulling it down. I'm spinning it with a string, so the string is pulling it up. True?
Yes.
Is it more or less than the Earth force?
More.
It has to be more, because which way does the acceleration point if you're in a circle?
Inward.
Toward the center. And if the acceleration points toward the center, where does the unbalanced force have to point?
Towards the center.
Toward the center, so the up has to be bigger than the down.
Oh,
And those are the only
realize
forces.
that's why.
And that's the only forces on it, right?
Yeah, if it's a little stopper on a string, those are the only forces.
But then on the top, it's mg and then tension both down, right?
Okay. Up here, you want to do this one. The Earth is pulling it down, but where's the string?
Somewhere.
Yeah.
It's also underneath it.
But then why is it smaller on top?
It depends on the speed. It could be smaller, larger, or the same.
Oh, so that's just for the visual of it?
Yep.
Okay.
Yeah.
You're staring off.
It's staring off into the middle
Wait, I'm
distance.
sorry.
Could you like check to make sure that?
Look at you go.
Well, I mean, it's might be wrong, I don't know. The numbers don't, it just seems weird.
Well, sometimes you just gotta do what it is, man.
I feel like if I did something wrong, that I just continue to do it wrong.
Here's a problem. 100 centimeters
Mhm.
is 1 meter.
That's so true.
No, I don't use.
I might want to color credit work a little bit.
no,
Jack,
Um,
you used Claire.
Yeah.
Use that Claire.
Hey Claire, she thinks that 100 centimeters is also 0.1 meters.
No way.
Wait, what is it? What,
Seriously?
It's one.
the exact same thing.
100 centimeters.
Yeah,
How many
meter
stick?
You got it wrong. No, okay, I did it right initially in my work, but I plugged it
Wait,
into
how many
every single
millimeters
thing
are,
wrong.
wait, is it 100 millimeters is 1 centimeter?
No, 10.
So, oh, because 1,000 millimeters is.
I swear
When
to
you're
God, it's
spinning it,
0.1.
the tension force changes in magnitude, right?
Yeah.
Mr. Battle.
Here, try it. Spin it around. Try to keep the speed constant and see where you feel more string force.
This is kind of a proportion, right, that I
Because
use.
it's like.
The north and south?
Does it feel like the string is pulling you more at the bottom?
Yeah.
It's because it is. Alright? Alright, so, here we go. Ready? Let's put this together so this makes some sense. So, at the bottom, your net force is the centripetal force. It's mv squared over r. And to represent your net force, how are you going to represent it mathematically?
MV squared over.
Yeah, but it's the tension force minus the weight.
Trying to set
That's
me
even
to the
funny.
side, that isn't.
And then you have mv squared over r is equal to ft minus mg. Is that cool?
And that works either way, because even if T is like smaller, it would just be.
Well, up here they're in the same direction, so we're gonna have to add them. So
Are you
up
talking about just
here,
the bottom?
yeah,
Oh, I forgot about that, that's my view.
Yeah.
Dude, this week's going.
okay? You guys with me on that?
Yes.
Next week's only a 3-day week though.
I know, it's a max.
So,
25 minutes.
That's
I think it's just because we just got back from break, so.
Okay, so
Alright.
now, here's the question. If you watch me spin this, okay, as you watch me spin this, right, it looks like it's going in a really nice circle here. I'm very happy with that. If I go slower and slower and slower and slower, eventually, do you see it fall out of the circle?
Yes.
Okay, so I'm going to go again, and I'm going to go slower and slower and slower. See it fall out of the circle?
Is that because MG is more than FT?
No. So we're talking about the top, right? So I want to know, can we represent the minimum speed?
Oh, I forgot about this.
How do we calculate the minimum speed? Well, here's what's cool about this.
Ew.
If I look at this equation, as I go slower and slower and slower, the left side gets less, because the v is going down,
Yeah,
which means the right side has to get less because it's an equal sign.
but MG is gonna stay the same, so.
But mg is the same, so what's happening to the tension in the string?
It's going down. and
It's
down.
going lower. And at the v min, that's when your tension goes to 0.
So it's that moment right before tension hits 0.
Yep.
So it's the limit as FT
We
approaches
don't need to
0.
involve those.
Please don't say that.
At least I'm not saying it's like the ratio test.
Oh, God, I mean,
I can't even with those, there's so many. A whole test on like 8 different, how to find if it, what, converges or diverges.
I don't even know what
Why is-
conversion diagram is.
Why is there